In this video, we're continuing to look at queries that require us to join two or more tables together. We're working again with our university database, which is deliberately simplified to make things easier to visualize. And let's assume that what we're trying to do is find the names of all students in the database who are both enrolled in CS105 and who are majoring in computer science. So the first thing we want to do is fill in the from clause by figuring out which tables we need. And in this case, we need three of them. We need the student table, because that's the only place where the students' names are found. We need the enrolled table, so we add that as well. And that's going to allow us to know who is enrolled in CS105. And then we also need majors in, because that will tell us who is majoring in computer science. And so all three of those table names go in the from clause, separated by commas. Now, as soon as you realize that you have more than one table in the from clause, you right away want to come up with your join conditions. And because in this case we have three tables, we need two join conditions. The number of join conditions is always one less than the number of tables. And one of those join conditions is the one that's going to allow us to connect student tuples to enrolled tuples. Here it is. We want the ID value from the student table to match the student ID value from the enrolled table. But there's a problem here. There's actually two different columns called student underscore ID. There's the one from enrolled and there's the one from majors in. And so if we're not careful, we're going to end up with a case where the DBMS doesn't know which of those columns we are referring to. So this is a case of an ambiguous column name. And when we get one of those, we want to prepend the name of the table and then a dot, and then we have the column name. So now we know that in this case we're trying to match the student ID column from the enrolled table. So we now have a way of connecting student tuples to enrolled tuples. We still need to bring in the majors in tuples. And one way to do that is to write a join condition that connects enrolled to majors in. In this case, the connecting column in both of the tables is called student underscore ID. And so here again we need to prepend. So we're saying we want the value in the student ID column from enrolled to match the value of student ID from majors in. Once you have your join conditions, you ask whether you need any other conditions. In this case, we need one that specifies that the course name from enrolled must be CS105, and we also need one that says that the department name from majors in must be comp sci. That ends the where clause. Those four conditions all are anded together to give us the complete where clause, and we have a semicolon at the end. And then finally, we're going to put name in the select clause, because that's all we need is the value from the name column in the student table. Now, we have to use the table name in the three places that you see here, because otherwise there'd be ambiguity. But you can also add in the table name for other columns, just to make it clearer where they're coming from. So these green table names are not required, but they can still be used to make it easier to know where a given column is coming from. One other thing we can do to improve readability is to use an alias for each of the table names. So up in the from clause, after the name of a given table, we can use the keyword as followed by an alias. And it's just going to be a name that we use instead of the actual table name in this particular query. We're not changing the name of the table permanently, we're just changing it for the purposes of this query. And then any place where we're currently using the table name student, we're going to use S instead. And so it makes things a little bit cleaner and a little bit more compact. We can do that for enrolled, so we're saying as E. Now it wouldn't have to be just a single letter, the alias can be something longer if we want. But now that I've said that I want to use E, any place where I have enrolled, I'm going to put E instead. And then majors in as M, and again, any place I have majors in, I replace it with M. It turns out the keyword as is optional, so we can omit it and just have the alias come right after the name of the table with a space in between. And so this is the final version of my query. Let's now trace through it to see how it gets executed. So we start out with our three tables, and I'm color coding here just to make it clear where different parts of the result are coming from. And as always, we start with the from clause, and because we have multiple things in the from clause, we essentially start out by forming the full Cartesian product of our three tables. And you can see the Cartesian product has these 7 columns, the 2 columns from student, then the 3 columns from enrolled, and then the 2 columns from majors in. And remember, the Cartesian product is all possible combinations of tuples. So we start by combining the first tuple in student with the first tuple in enrolled, and then that pair of tuples gets combined with all 5 of the tuples in majors in, and that gives us the first 5 rows of the Cartesian product. Then we keep the first tuple from student, but we now combine it with the second tuple from enrolled, and that pair gets combined with all 5 from majors in. That gives me the next 5. And we keep doing this. We end up with 125 rows in the Cartesian product. Now obviously we don't want all of these because there's lots of combinations that don't make sense. For example, if you look at this row of the Cartesian product, we have the student tuple for Jill Jones, whose ID is 1, 2, 3, 4, 5, 6, 7, 8, and that is combined with a tuple from enrolled for a student with a different ID number, and that is combined with a tuple from majors in for a completely different student. So 3 different students are in this one row of the Cartesian product. So that's where the join conditions come in. Those join conditions are going to narrow things down to only the combinations that actually make sense, in which all of the ID values are the same. So the first row that is left after the join conditions comes from combining the top row of all 3 tables, because those top rows happen to all involve the same ID number, which is the ID for Jill Jones. The next row that's left is the one that involves Alan Turing's information, so that's the second tuple from student, the second tuple from enrolled, and the third tuple from majors in, all of which have his ID number. Then we have 4 different things for Jose Delgado. The first 2 are from pairing his row from student with this row from enrolled, because Jose Delgado is enrolled in CS 460, and then these 2 different rows from majors in, because he happens to have 2 different majors. He's majoring in math, he's also majoring in English. And so that gives us these 2 rows, but he's also enrolled in CS 510, and so that gives us the last 2 rows in which his student tuple is combined with this last tuple from enrolled and each of these tuples from majors in. It's worth noting that Audrey Chu does not make it into the result of the join conditions because although she is in the student table and in the enrolled table, she is not in the majors in table, which means there is no row from the Cartesian product in which her ID shows up in all 3 of the ID columns. Similarly, Count Dracula is in the student table and in the majors in table, but not in enrolled, and therefore there are no rows from the Cartesian product in which he survives the join conditions. So we have these 6 rows left. We now apply the remaining conditions from the where clause, which limits us to just this first row, and then finally we go up and we do our select clause, which gives us just the value from the name column, and so Jill Jones is the only student enrolled in CS 105 and majoring in computer science.